On this episode of TechStack, IAA Mobility, Munich, software-defined vehicles. What do they have in common? Jim McGregor from TIRIAS Research here for TechStack, and I'm here at IAA Mobility in beautiful Munich, Germany. And I'm here with Suraj Gajendra, who is the Vice President of Software and Solutions for Automotive at Arm.
Yep.
And we're talking about, we're obviously one of the biggest tech shows for automotive in the world, and this is really great. Everyone's introducing new vehicles. They're talking about what they can do from a software perspective, from a services perspective, but still it comes down to the technology. And you guys introduced recently the Zena Compute Subsystem platform for software-defined vehicles. Now, this is not just a simple subsystem for, infotainment or ADAS. It can pretty much do anything. So you want to kind of give us an overview of Zena?
Absolutely. Again, you got to, to understand Zena, Jim, you got to go back and understand ARM and how and what do we do in the vehicle compute architecture, right? So we've been supplying to the automotive industry for over 25 years now. And we've been
the leading architecture in the automotive industry.
The leading architecture in the automotive industry, absolutely. So, but at the same time, it's just that we've been supplying the IPs, the core technologies, the core compute technologies. But then, when you're looking at where automotive compute is going today, it's just exploding, right? I mean, be it the cockpit, be it the AI applications in the cockpit, be it the ADAS, be it autonomous driving. So and then the pace at which the whole technology is moving is unbelievable, right? Now, what we basically thought about it internally is, okay, look, we can continue to supply and we will continue to supply our core technologies to our partners. But at the same time, how do we ensure that our partners can actually go to market at a much more quicker pace, right? How can they actually deal with the complexities that we are actually looking at in today's automotive compute architectures compared to what it was before? So the whole idea of Zena was, okay, instead of supplying individual IP components, how do we put the whole subsystem together, right? I mean, put like, say, a 12, 16 core subsystem with safety capabilities, with the debug elements, but at the same time, ensure that we leave differentiation to our partners, right? For example, partners want to have their own AI accelerator. Absolutely. It's an investment that they have done and they have to continue, right? So where we've stopped is ensuring building the compute subsystem primarily from a CPU and core compute aspect, at the same time allowing enough flexibility for our partners to differentiate. So building a subsystem will help them not to deal with the general purpose compute aspects and the complexity that it has. For example, it's definitely, today we're talking about 16 32 core subsystems in automotive. A few years ago, we were talking about 4 8 core subsystems. So the complexity has significantly gone up. And we here are taking a lot of that burden away from our partners and ensuring that we're pre-verifying the subsystem and supplying that to the partners, right? So taking the burden away from our partners on complexity and integration. B, allowing them to go to market at a much more faster pace. And C, ensuring that they can differentiate with core, like differentiation technologies that they can actually bring in. So that's what Zena is all about. And that's what we will continue to do in this system.
And the differentiation is kind of critical because obviously it depends on your sensor array, it depends on your vehicle type, it depends on the options you want to offer within the vehicle as well. So there's a lot of different solutions. But you did design this with some of the critical elements with that security and that reliability in mind.
Exactly, absolutely, right? Look, again, going back to what your previous question, it's about Zena is not just for, say, a cockpit application or an ADAS application. We know that, again, the compute requirements in a vehicle is very diverse, right? So you have, zonal controllers and domain controllers, and, partners can take our Zena architecture and enable, we do allow modularity. We enable, aspects where they can sort of, instead of using 16 cores, they can basically use 12 cores, for example, depending on what application that they need. At the same time, be it, say, a monolithic solution or a chiplet solution, can be anything that they would actually implement. So starting from, say, cockpit applications, zonal controllers, domain controllers, or even central car compute ADAS applications, Zena is actually very, very flexible, right? And that's the core of it. And when we build it such a way that we keep very, very close eye on the mixed criticality of aspect of it, safety and security. So we ensure that partners can enable mixed critical applications on a subsystem like Zena, depending on what they're trying to do.
Now, what I was most impressed about is not just the fact that you're talking about possibly reducing their design time for the SoC by 12 months,
Right?
but you're actually talking about reducing their software design time by up to 2 years.
Right.
I mean, that's
Exactly.
huge.
That's huge. That's huge. And again, those numbers, Jim, we just didn't pluck it out of the thin air, right? Because see, I'll give you a little bit of history here. When we launched our 2021, generation of IPs, automotive IPs, the first silicon and the platform, to be really honest, became available for general software development was sometime in like early 2023. Okay, so the silicon was available end of 22. Platform became available for software development in early 23. So that's 2 years, right? Now, when we actually launched our 2024 IPs, when we were preparing for the launch and when we were preparing for that generation of IPs, we were like, look, essentially, the landscape for software-defined vehicles have significantly sort of improved and changed over the last 3 to 4 years. So it doesn't really help for software developers to get their hands on the platform 2 years after we launch an IP, right? So what we did in 24 was we partnered with some key EDA partners, okay? Siemens, Synopsys, Cadence, for example.
Those are the big three.
Exactly, exactly. And we enabled virtual platforms for our IPs on day one of our IP availability, right? So in March 2024, when we launched our 2024 lineup of AEIP, Automotive Enhanced IP, we basically had virtual platforms for all those IPs on the same day. Not just that, what did we do? We also had the SOFI ecosystem backing us because we've been very, very active in enabling a much more standard software ecosystem for automotive since 2020, 2021, right? And we ensured that the software ecosystem and partners who are in the SOFI community have access to the virtual platforms and have the foundational software enabled on that virtual platforms on day one, right? So not just that, we worked with our cloud service providers and ensured that there is instances of the virtual platforms with the SOFI software in the cloud infrastructure. So our software developers could just basically use that infrastructure to start this application development.
So we're saying that OEMs, tier ones, and application developers all have access to that software, even before the SoC is done.
Exactly. On day one of ARM IP availability. That's what we achieved in 2024.
That's incredible.
Absolutely.
Now I have to ask, but who is, I mean, obviously we're seeing that the vehicle market, the software-defined vehicle market is evolving over time.
Yes.
Early days, all the OEMs want to do their own silicon, and they figured out it was harder than they thought.
Yes.
So I mean, but now we have design houses, we have ARM partners, we have who is kind of the ideal customer or partner for the Zena platform?
I mean, look, Zena is, be it silicon partner or OEMs who are actually doing SoCs for the first time or tier ones who are actually looking at silicon design. Zena is for everybody, right?
Okay.
And again, obviously, initially when you look at it, it's like, okay, really for silicon partners because they already have their SoC architectures and SoC legacy that they have been building. But again, when you look at where do they have to differentiate, right? Where do they have to invest? They don't want to invest in the general purpose compute part that we are sort of helping them anyway, right? So yes, Zena, from that standpoint, and because of the flexibility that we offer in Zena, even silicon partners absolutely, they've been discussing this with many of them.
And they're still going to the next generation.
Absolutely,
and you have a lot of, especially in the embedded industrial segments, you have a lot of partners. They're not doing custom cores, they're using the ARM technology as much as they possibly can.
Exactly. And the complexity is not reducing. The complexity is increasing every single generation. Again, not just from a design perspective, but complexity from a process node perspective is also, increasing every single process node generation. So for a silicon partner, for anybody, when they look at, okay, this is what I need. This is what my workloads need. Here's what I want to do with a platform. Oh gosh, this is so complex to put the whole thing together when you're talking about AI applications and stuff like that. So what Zena basically does is helps them along the way to minimize that complexity that they have to take versus what we can do for them, right? At the same time, ensures that this is not going to be like a traditional 3.5 year design cycle. They can actually cut it down significantly up to 12 months by taking something like a subsystem from us.
Yeah. Now I have to ask you, because I was just part of the ARM event that gave us the deep dive on the Lumix platform, CSS platform for mobile. And I'm looking at this platform, I'm like, wow, with the flexibility of some of the small C1 nano cores and and the SME2 engine and everything else, there's a lot of things that I could do in the embedded environment. So I'm kind of thinking of this, especially with the security, with the reliability. I'm thinking robotics for medical applications. I'm thinking industrial applications. I mean, what other types of applications do you see beyond just automotive for Zena? Because your partners will find them.
Again, for us primarily, we've designed Zena for the automotive market, right? We've enabled it for automotive, again, taking into aspects like safety and cybersecurity and real time into account, right? Again, and when you look at some of those requirements, they're pretty much similar if you have a robotics application as well, right? So the whole idea with Zena is, okay, again, it's up to our silicon partners to enable whatever application that they would want to enable, but our focus is wherever there is safety, reliability, real-time security, and complex compute architecture that they have to go enable, we can help them with Zena. That's the intent.
Okay, no, that sounds really good. Thank you very much. And I have to ask you one last question.
Sure.
We're still in day one. I know it's hard to see everything that's at the show, but is there anything at IAA this year that really excites you?
Gosh, there's so much happening at IAA. I mean, every year when you actually come here and see one key trend that I see, Jim, is about how, increasingly you have the whole ecosystem coming together. It's not just the automakers anymore. So you have, the software players, you have the cloud service providers, right? I mean, you see a big booth, AWS, for example. So you have, and Google, right? So you have, automotive is evolving. And as we say, software-defined vehicle is really, really changing the whole landscape. And you can see that here, right? I mean, it's just, that's what strikes me. It's just, it's no longer just, automakers, but you see the whole ecosystem coming together and solving the most critical problems in automotive.
And that probably amazes me the most is the fact that AWS and Google are everywhere here, especially AWS. I think they've got more talking slots than I've ever seen in an event. But the fact is that, I think everyone was really afraid of the internet companies taking control, of the automotive and the user interface and everything else. And they're really not. I mean, these guys have really come and they're offering tools like Google's now offering through the AI cloud, the ability to build custom agents to the OEM. So they're not trying to take control away.
Exactly. And then this is the beauty of this, right? I mean, look, again, the complexity of where we are, going with, say, a future AI-defined vehicle, it's not going to be built by, one company or one OEM, right? So we will have to work together, right? It has to be the giants like AWS and Google on one side. On the other side, you have the OEMs and tier ones, and then you have silicon suppliers and technology suppliers like us. It's just, it has to be a collective effort, and you see that in action here in IAA.
So Suraj, thank you so much for joining me, and look for more info on IAA Mobility and all the technology related to it on TechStack.